Back in the earliest days of personal computing, getting a word processor to talk to a specific printer or hard drive was an engineering nightmare. You had to physically wire connections and write custom command line code for every single piece of hardware. Mainstream adoption was a mathematical impossibility as long as users had to double as their own hardware engineers just to save a document. Then Windows 95 arrived and virtualized the hardware. It placed a unifying layer between the user and the disparate chips and drives inside the machine. For the first time, users simply launched an application, while the operating system invisibly handled the translation to the physical components. Technological revolutions scale when the complex infrastructure finally disappears from the user's view. Right now, Web3 is trapped in its own MS-DOS era. The entire ecosystem relies on an imperative execution model, which forces the user to dictate exactly how a computer executes a task. To execute a trade, you manually configure RPCs, purchase gas tokens, and navigate bridges. You drag an asset through nodes, accumulating fees. Because this path is public, bots see your instructions and swarm the transaction to extract MEV, profiting by reordering trades. Blockchains cannot scale to global finance if every participant is required to manually wire their own transactions. Anoma functions as a distributed operating system that sits above all existing chains, unifying the fragmented landscape into a single development environment. It moves the network from an imperative model, telling the computer how to do a task, to a declarative model, where you simply define the outcome you want. The primary unit of this model is called an intent. An intent is a cryptographically signed message expressing a desired end state, like trade asset A for asset B, without dictating which liquidity pools or routing paths are used to get there. By shifting the burden of execution to the network, the protocol completely decouples human desire from blockchain mechanics. Once you broadcast an intent, it enters a generalized gossip network, where it is picked up by the operating system's background processes. This is the domain of solvers, specialized competitive actors like the Project Barter. Their job is to crunch the math and find the optimal route to execute a digital barter across any connected chain. When a solver finds the path, Anoma executes it across disparate blockchains, using specialized components called protocol adapters. These adapters allow Anoma to virtualize the state of any chain, treating Ethereum or Solana exactly the same way a traditional OS treats different microprocessors. To protect the user, native privacy layers like Fairblock and Encipher encrypt the intent before it is executed. This serves as the OS's built-in firewall, shielding your trade from front-running bots in the mempool. This combination of competitive solvers, the universal adapters, and programmable privacy transforms underlying blockchains into interchangeable compute layers. This leads to the real turning point for the industry. When do we stop talking about blockchains and start simply using apps? Anoma's abstraction of liquidity and chain lock-in creates the architectural path for a decentralized super app. Imagine a single interface where you can chat, trade, and coordinate globally without ever needing to know which blockchains are processing the data in the background. Utility in Web3 emerges only when developers are freed from infrastructure plumbing and can focus entirely on the user experience. It's similar to how we use the internet today. Everyday users never have to think about TCP/IP packet routing when sending a simple mobile message. The mark of any mature technology is its ability to completely fade into the background. Anoma's operating system is the mechanism required to finally hide the wires, abstract the chains, and make Web3 as invisible and as indispensable as the internet itself.